Today we will be getting ShiftScan installed, as well as going through the steps to get Python installed if you don't have it, and Conda installed if you don't have it. I'll add chapters to this video so that you can jump ahead depending on what you do and don't have. The first thing we're going to do is check if we have Python. So to do that, we're going to open up the PowerShell prompt. So we're going to look for PowerShell. There it is. Open that up. So get that up there. The first thing we're going to do is just type in Python space -- version and then hit enter. Now, if you do have Python, something along the lines of Python 3 point whatever will probably show up. If, like me, you don't have any Python, we'll have to go get it. So we can close this for now. And what we're going to do is go to our browser. This is not my laptop, so don't judge me on the edge. It's www.python.org/downloads. So that'll take a second. So here it will automatically detect your operating system, and you just click the yellow button there, and that should get the installer downloaded. It normally goes to your downloads folder. You just need to open that. Or you can go, to your documents and open it from there. The important point here is to add the Python executable to your path. That basically means that we can pick it up anywhere. And then you can go ahead and click install now. So it's going to sit and think for a little bit. So I'm going to pause the video here because it's going to take a couple of minutes, and then I'll come back as soon as it's finished successfully. Okay, that didn't take too long, probably about a minute. The setup is successful and all done, so we just need to close that, and it should be done. And oopsie, easiest way to check is just to go open that PowerShell again, and right, so we're getting Conda installed. To do that, I'm going to quickly go to the GitHub repo because there's a lot of stuff we have to type, and I don't want to do that. I'd rather just copy and paste it. So we'll go to GitHub, to the ShiftScan. Right, we'll go there. Oh, not connected. Give me a second. All right, so let's try that again. We'll put in www. Let's see, that should do the trick. There it is. This is very strange. Anyway, we can go to other docs, Windows. Right, and then what we're going to want to do is copy this line here. Control C. I'm going to go back to our PowerShell and Control V, paste that in. And what that's doing is basically copying down the installer from the web and putting it into this miniconda.exe file. So that's going to take a second. I'm going to pause the video again so you don't have to sit and watch this be downloaded, and we'll be back in a minute. Okie dokie, so that has run. And the next thing we're going to do is just run the installer. So the installer is down, but we haven't actually run it. So we're going to go back and just copy this line again from the GitHub repo. So that's Control C, go back to the PowerShell. Control V, and all this does basically, it says, hey, start the installer, run it quietly, and then just let me know when it's done, kind of thing. So we're going to run that, and again, I don't think this step takes particularly long, but I will pause the video and set off again once it's done running the installer. Okay, we are once again done. That really didn't take very long. I think about 30 seconds, certainly under a minute. And so basically the installation of Miniconda is now complete. And so we can just go ahead and we can say delete miniconda.exe. Whoa, there it is. Miniconda.exe. There we go. All right. So what we're going to do is we're going to close this PowerShell terminal. We should now have, and we can close this. Actually, no, we're going to have to copy and paste some more, so we'll leave that. What we're going to do now is, instead of opening a PowerShell, we need to open an Conda PowerShell prompt. Okay, so that's going to be a new tool now that Miniconda has essentially put onto the computer. So we're going to open that up. And this is where you'll have to run ShiftScan each time, not normal PowerShell. At the end here, you can see it says base. This is now our base Conda environment, and we will be installing ShiftScan and creating a ShiftScan Conda environment. But to do that, we're going to need Git, because we're going to clone the repository from GitHub. So we're going to just say Conda install, and we're going to say -y, that's basically just say yes to everything, and we want to install Git, and you're going to hit enter. All right. Again, this shouldn't take too long to actually run and get installed, but I will pause the video once again so you're not staring blankly at a screen with me, and I will pick up as soon as it's done running. Oh, there it goes. This really doesn't take very long at all. I think a minute or two, although different systems will run at different speeds. Oh, wait, let's just see, just in case. Okay, no, it's still thinking. I will come back as soon as it's done. Okay, so that is now done. It did take a minute. It sort of looks like it's stuck, but it's fine. It eventually gets itself in order. So that's Git. So now we can move on to actually installing ShiftScan. So what we're going to do at the moment, we're sitting in users. So this is my user profile. So what you're going to want to do is move into wherever you want to store ShiftScan. So I'm just going to move. Okay, so I accidentally ran a few more steps ahead. I thought I was recording and I wasn't. But basically, Git gets downloaded, and then all the stuff down here we're going to quickly repeat. So I'm going to scroll through. I've undone everything. So let's go here, and we'll start at the beginning. Okay, so that's basically saying because I deleted everything, I've reset. Don't worry about it. Okay. You know what? I'm just going to close it all and start over. That way it's nice and clean. So we need Anaconda PowerShell. Okay. So now Git has been installed. And we can go ahead and install ShiftScan. So to do that, we're going to change directory, which is CD into downloads. Now I'm going to hit tab, and it's going to tab complete for me, so I don't have to type the whole thing. And we can type ls, and there's nothing in there. If you have the Python installer, I think I deleted that as well. You can go ahead and delete that. You don't need it anymore. But this is where we're going to store a ShiftScan. So you don't have to move into downloads. You can navigate to whichever folder you want to put ShiftScan in. That's fine. I'm just going to put in downloads for this example. So what we're going to do is we're going to say git clone https. This is in the GitHub repo, so you can just go ahead and copy it if you want. But we're going to go, whoopsie, no, we want to hit there. So that's me. And then we're going to go shiftscan.git. And basically what we're doing here is we're cloning the ShiftScan GitHub repo down to our local machine. So we can do that. This doesn't take very long at all. And so now I can see ls, there's ShiftScan. So if we do the same thing, we go over here, we can go to downloads, and there's ShiftScan. What we're going to do in the terminal now is basically go into ShiftScan, and then we're going to go into the scripts folder. We're going to do the same thing over here, which is basically CD. We want to go into ShiftScan. I'm going to tab complete again, and then scripts. And tab complete, you literally just hit tab and it finishes it for you. And then hit enter. And now we can see all these files and folders, which is exactly the same as this over here. Two different views of the same thing. So the first thing we're going to want to do is just get that Conda environment set up for ShiftScan. So we're going to type Conda env create dash file. Ooh, that's not useful. File equals shiftscan.yaml, which is this file right here. So basically all it's going to do is going to go dig in that file, find all the dependencies it needs to download, and create the Conda environment with all the necessary packages and whatnot. So you can hit enter. Now this is going to take a little while. It can take, I haven't actually timed it, but I think it could take up to like 5 minutes. It's different. I've done it a lot on Mac, not so much on Windows. But yeah, so I'm going to pause the video again and wait for this to download, but just do be aware that this can take a while. Okay, so it's done. I didn't time it, but it probably took about 5 minutes. maybe less. But we're going to go ahead and just copy this. You can type it out as well if you want. Control C. Oh, I didn't. Oh, you know what? It's fine. Conda, activate, ShiftScan. And now you're going to see that this base is going to turn when we hit enter to ShiftScan. So we're now in the ShiftScan environment, in a new little ShiftScan box, if you will. And every time you want to run ShiftScan, this is the only one you have to run. So you would open up an Anaconda PowerShell and you would write conda activate ShiftScan, and then you can run ShiftScan. So to do that, we're going to run ShiftScan using the example data. And just know that the first time we run ShiftScan, it does take a while. I haven't actually timed it on Windows. I know it takes a lot longer on Windows than it does on Mac. Mac takes about 10 seconds. It just kind of hangs, or it seems to hang, and then it runs. And basically what it's doing, it's installing or it's importing all the packages, and then it kind of stores that so it knows for next time, so it doesn't have to do it every time. So the first time you will ever run it, it will seem to just take forever. I will time it on Windows to see how long it actually takes. But anyway, to run ShiftScan, you can say Python. The main script is called multi processors -- main.py. The input is going to be the example data, which is in the same folder that we're in at the moment. So if we go in here, come on. There it is. So if you're pointing somewhere else, you'll need the full path to where it is. But yes, so for the input, you just point to the folder. For the metadata, we're going to look at example metadata, tab complete, and then we actually need to point to the file itself, which is metadata.txt. And then output, we can call it whatever we want. Let's call it demo output. And that's going to write out to the ShiftScan scripts folder. If you want it to go somewhere else, you could put in users, for me it's Simonson, documents, whatever, wherever you need to do, you can just fill in the full path for all of these. Anyway, let's just run it with the demo. This, as I said, it does take a while. Did I make a multi-processor? Oh, it's multi-processor. Okay, Samantha. Typo. There you go. All right, off it goes. Like I said, this does take a while. Let me get my timer out and have a look at how long this is going to take. Oh, no, there it goes. Okay, it doesn't take particularly long at all, so that's good. Normally in Windows, it can take a little longer. So don't be concerned if it does take a little longer, just sort of nothing happens. I do know that it can take time on some Windows machines. This is only the third one I've ever tested it on. Great example here. This is a warning. Nothing has gone wrong. They are handled in the script. I just don't have a way of stopping it from being printed out like this. But they are handled, so don't stress. Unless the whole thing actually crashes and it's an error I've never come across or a warning I've never come across before, it's fine. Anyway, so that's now run. It's finished. If we go to the script, whoopsie, come back. We now see that there is a new demo output. Now this, don't delete it. This is what I was talking about. It can sometimes take a while to run the first time. It creates this. Leave that alone. It just means that every time you run ShiftScan, it'll now be super duper fast. So we can go into the demo output that it's just created, open, and these are our 4 output files. The next step is optional. You can, absolutely just, the most useful stuff is probably final results. That's where the melting temperatures are and all the other details. This is the coordinates for the actual curve. And these really may or may not be useful to you, but they are part of the visualization, which we will do next. So here we're going to run the visualization. So we say Python visualization.py, and the input is going to be your output folder from the previous one. So in this case, that's demo output, right? So you can just go ahead and hit enter. Now, again, different systems take a different amount of time. And an interesting thing I've bumped into is on Chrome, it seems you can type this in, no problem. But if you're using, whoopsie, come on, let's highlight this properly. So this is what you're going to want to say, Control C. And basically this is now running on your local server. So you technically don't even have to be connected to the internet. We're just opening up a page. So we can go over, we can close these. And Now, because this is Edge, it does something very weird. So if I paste this in, which would work in Chrome, I haven't tested Firefox, so please do let me know if you do. It's going to say can't find it. However, if you type in local host 8050, which is the port, it works. I'm not really sure why Edge does this, but Chrome, you should be able to just put in that the original thing that it sends. If that doesn't work, do try this local host with the port, which is 8050, and then you have the visualizations that you can play with. Basically, you know, I'll go through it real quick. This is the plate overview. So how many of your controls have failed, which ones failed, why they failed. This may or may not be useful to you. It's if the same well is failing across a lot of plates, which means that there may be an issue potentially. We have automated pipetting. So, you know, we found many a clogged pipette this way. The next thing is the control overview. So this is the distribution of control melting temperatures before and after. The outliers are removed. So a great example is here. You can see sort of two blobs. And in this stage, the second blobs have been removed and the results would have been based only on these. If you scroll down, you can see the original curves and sort of here, this one failed. You can see why. The next thing you can do is the melting temp overview. And this is basically just a plate view of your results. You can color it by melting temperature or z-score. Totally up to you what you want to do. I like melting temperature. I just think they're prettier colors. And if you click on, all your plates are there, but if you click on an individual well, the curve will show up. Let's look at a control one. That'll be nice and pretty. And similarly, these failed ones, these sort of gray, black, charcoal colored things, you can see why they failed. You know, there's no sigmoidal there. But it allows you to explore your data, and also this is very useful for finding edge effects or sort of weird patterns in the data that may show some pipetting issues. Finally, we can go to the hit list, which is really the business end. These are the default hits, which are defined by our newly defined z-score distribution way of finding hits. But you can absolutely use the more traditional, you know, n standard deviations away from a control mean, or the number of degrees away from the control mean. We'll go with degrees. We'll say, yeah, we're going to do 2 degrees away from the control. The average control melting temperature, I only will look at stabilizers, and we'll leave the amplitude cutoffs for a different day. And I'm going to say update. Right, so now I have 18 hits left over. You can click on the different rows, and the original sort of sigmoidal curve will come up, as well as the first derivative. The blue line is showing the melting temperature for that well. The red is showing the average control for the plate. If you decide for whatever reason, oh, that's a really terrible curve, I don't like it, you can just hit the little red or gray cross. Okay, it changes color, and that gets rid of it. Another thing you can do is generate all curves of your hits. So you scroll down and it's all of them. If you have over 50, it will only display the first 50. This is unfortunately a limitation of Plotly. Nothing to be done about it. If and when they can do more, I will sort it out. Another thing you can do is generate summary graphs. This is really only useful if you have fractions, really, but here's the distribution of your hits. So these are not hits, these are your controls, these are your hits. You might be like, oh, well, why is that not a hit? That looks like a hit to me. But then you see the relative amplitude is 2, and we had a cutoff of 1.5. So basically the amplitude of this experimental curve was just too big. And we said, no, only 1.5 times as big as our control is acceptable. If we change this to 2 or what was it, 2.1? So we'd have to, if we change it to 2.2, this would be accepted as a hit. And then we have the hits colored by fraction. Sorry, that's my cat. Or fraction colored by plate. And this is, so plate 1, most of my hits came from fraction 1. Plate 2, most of my fractions came from, most of my hits came from fraction 4. When you're done, you can just click the export button, click that, and it will download this file to your downloads. You can rename it, whatever you want to do. But yeah, I think that's about it. Please let me know if you enjoy ShiftScan, if you can think of any other useful features. But good luck with your analysis.